questions over Monday's discussion? None? I was afraid of that. So when there's none, I come up with a few of my own. Do that back. So how many significant digits do we want in our answer? So notice it's a mixed operation. We do the division first, and then we're gonna do the difference. So that's how you wanna do it here. I'm gonna go 2.37 divided by 5.961, and I get the number, and it trails off. Now, if this was the only problem, we might go 3 digits here, 4 digits here, got around this 3. The decimal's present, so we start on the Pacific Ocean side, ignore that 0, count off our 3, and that's how I'd want to report that to 3 significant digits. 3 here, 4 here. That's how I'd do the multiplication division. All right, now we're right here. Now we're getting somewhere. And thank you so much for pointing that out to me, Cassie. All right, see now I'll remember you quite well. So I'm gonna go up to my register. I'm gonna grab that number and go and get the negative sign. Absolutely. So what's our rule for addition, subtraction, decimal position? All right, there's our answer. Now, unfortunately, if you use the rules incorrectly, you still might want it to round to 3. That's what you said right at the beginning. Everybody said 3. However, it may not necessarily work out that, like, we had something like that. Then we'd round to right here, right? Any other questions? So I like to talk about unit equations and unit factors. A unit equation is a statement of 2 things being equal, like 365 and a quarter days in a year. They equal each other. Here we see $1 is 10 dimes. 1 dime is 10 penny. 1 milligram is 1,000th of a gram. 1 kilogram is 1,000 grams. Now, if you memorize all these from the previous slide, and you need to put it together in a unit equation, you want to be a little careful because students like to do this. Here's what students like to do. They like to go 1, so don't do this, milli, oh yeah, 10 to the negative third, and that equals, well, this is not at all right. So I think the other day I said, how many years, century, and you said 100. And if I said 100, how many centimeters in a meter, you'd say 100, and that was all correct. But let's look at that a little bit. It is true that 1 milligram, put a 1 in front of the metric prefix, then you move that prefix in front of the base unit. Now, if we don't like fractions, and I don't like fractions, there's 1,000 milligrams, 1 gram. So notice I've multiplied both sides of the equation by 1,000 to get rid of that. So now I have 1 gram and 1,000 milligrams. And that might work out kind of nice. Let me just back up and see if we can make sense of this one here. 1 centimeter is equal to 1 times 10 to the negative second meter. 1, 2. And if I don't like that fraction, I multiply both sides appropriately and get 100 centimeter, 1 meter. So this and the milligrams, if you kind of have that in the back of your mind, when you put together some of these unit factors, it'll help you from getting tangled up and getting the wrong answer. All right, so the metric prefix goes in front of the base unit. So these are nice, and you might be able to say them like there's 12 eggs in a dozen, 144 bottle rockets in a gross of bottle rockets, 24 beers in a case perhaps, all those great things. But more importantly, what comes from a unit equation is unit factor. So each one of those equations over there, I've divided both sides by one of the units. Let me see if I pull that back up. Over here, if I take $1 equals a dime, and I'm going to divide both sides by 10 dimes. Because in math class, we learn what we do to one side of the equation, we do to the other. Well, that's what's 10 dimes over 10 dimes. That equals 1. Now, 1 might be the loneliest number there could ever be, but it's a perfect nice number because I can multiply by myself by 1 and I'm still me. I could divide myself by 1 and I'm still me. Would I want to divide myself by 2? I've always wanted to pull out a cantaloupe now and a machete and cut it in half, but I'm too scatterbrained and busy to do that demo. All right, so when you convert pounds into kilograms or grams into pounds, you don't want to change the physical identity. Just like me, if I wanted to convert my 150 pounds into kilograms, I wouldn't want to cut myself in half. So, and then we could go the other way too. I could have divided both sides by $1, and then I'm gonna have something like 10 dimes over $1. So both these unit factors equal 1. They have a reciprocal relationship. So once again, something that works just as well as this one is 1,000 milligram over gram. And of course, there's the reciprocal of that. 1 gram is the same thing as 1,000 milligrams. That's because a milligram is a thousandths of it. Why do I make a big deal about unit equations and unit factors? Because I want you all to be able to understand how conversions work and be successful at doing them. Because in chemistry, we might want to convert, if I burn 20 grams of oxygen, how many grams of CO2 can I produce? And you're going to have to do a bunch of conversions to get that to work. How many dollars are there in 237 nickels? I know there's 20 nickels in $1, so that's my unit factor. Those equal the same. So this is equal to 1. So I'm going to give you the right amount of change if I was a teller at a bank. But more importantly, the unit of nickel cancels out, and perhaps if you know in the back of your head that $1 equals 20 nickel, you might be saying, oh, do I need to divide by 20 or multiply by 20? Well, maybe it's obvious to you right now, but when we change this to moles of carbon dioxide and 44 grams of carbon dioxide, it might get a little more complex with the thinking. But the unit factor helps us factor out units. Those nickels cancel out, and I'm left with the unit of $1. So now it's gotten a little more complex. How many kilometers are there in 254,987 centimeters? So the one trick here is here we have centimeters, here we have kilometers. We have to go through the base unit. Maybe we wouldn't have to, but we would anyway without knowing it if we just knew some of these exact things. So notice here's 1 centi. Centi is 1 times 10 to the negative second meter. All right, so my centimeters are going to go away. All right, so I want the unit of meters to go away, so I put meters down in the bottom, and 1 kilometer is, notice I take that metric fix, put it down there, 1 times 10^3, and just for fun, you'll get the same answer if you did 1 meter, 101 kilometer, 1,000. These are the same, but I'm sure you see how to do that. Centimeters cancel, meters cancel, and I can pull out my calculator. 2.5 kilometers. All right, I'm gonna see if I can do something here. Looks here like what we might call the base meter. And there is a decimal. And I said I like memorizing that table in group 3. All right, what do we have right here? We have milli, 10 to the negative third. What do we have here? We have micro, 10 to the negative 6. What do we have here? We have the nano. Here's the pico, 12. Coming over this way, we have kilo, third, have meg, 6, and we have gig, 9. So I think this works out kind of nice. If I look at this number here, 30050. Let's pretend I didn't have this handy dandy mnemonic here that you're gonna love and appreciate. Normally we'd proceed this way, right? And I would say, all right, I need a unit factor. And my unit factor needs to have meters down below. And we're doing nanometers here. So I put my nanometer right there. And then I ask myself, what is nanometer? 10 to the 9th. And don't erase that, or don't write 10 to the 9th anywhere up there. Get your 10 to the 9th down here. Put a 1 in front of the metric prefix. Now you get to practice using your calculator. At least I do. I always like it when students correct me, like getting the negative sign all messed up. So 0.00. See, I already messed up. I think I'm not chewing gum. I got 4 zeros there. There, 4 zeros. 15200 divided by 1 times 10 to the negative 9th. And my calculator spits out 1500 nanometer. And looky here, if I say, oh, there's where the nanometer decimal would go if we wanted to put one there, and I can see how that moved across. Now we got this one figured out. How about micro? I'm gonna look at this and I'm gonna say 15.2. How would we formally do it? We'd have to do something like this. Now I wanna put micro in here. Micro, 1 micro with meters. Meters cancel, I'm left micro. 0.0000152 divided by, and I get 15.2. That's what I got there. Now on my calculator, if you have a Texas Instrument like this, here's what I type with my keystrokes. divide, and then I go 1, and then there's this key on my calculator. It looks like this. And I hit it, it puts an E there, then I hit the negative sign, and I hit 6. The 1 e to the 6 means times 10 to the negative 6. Real convenient. You'll want to learn how to do that. So in my mind, we did the fun ones. Here's the horrible ones. Why would we want to do this? Well, I suppose this will be good for me because I don't worry about centi a whole lot. We figured out at 10 to the negative second. So I'm feeling a little lazy. I'm gonna just go, we want centi, gotta get rid of meters. 1 centi, 1 second. That's probably right there, right? So I can probably imagine my number's gonna be 0.0015. Let's see if we get that. All right, here we go. Decimal. 1, 2, 3, 4 zeros, 1, 5, 2, divided by 1, hit the E key, negative 2, enter, and my calculator spits out 0, 0, 1, 5. Notice that's what I get if I put the decimal right there, 0, 0, 5. All right, now with the stupid kilometers, we'll go ahead and do that. 1 kilometer, 1,000 meters, kilos, 1 times 10 to the third. I got lazy with that. 0.000152 divided by 1,000. My calculator got tired and lazy. Talked back to me. It says I'm gonna put this in scientific notation. So let's just see if that makes sense to us. Draw this to scale. All right, kilo. That's like putting the decimal here. 1, 2, 3, 4, 5, 6, 7, 8. That makes sense. 1.52 times 10 to the negative 8 kilometers. All right, it is. Saw you shaking your head. All right, any questions with these conversions? All good stuff with the metric. So shortly, we're going to look at physical properties, chemical properties. Physical properties are something you observe and it doesn't change the substance. Like you can say snow is white. We can say water has a density about 1 gram per mil. So density is a physical property. If we say ethanol is flammable, how many of you know that ethanol is flammable if you were in lab? So density is a physical property, and I can imagine it coming from a unit equation. I told you I like unit equation. If I have 1 mil of ethanol and I go weigh it on the balance, it's going to weigh that amount. Now density is set up this way. We like to say it's mass per volume. So if I divide both sides by 1 mil, it puts the mil like that. And so here's a word of advice. Whenever you see these slashed units, think, man, my chemistry professor, he gets all excited about unit factors. I'm going to say, make this look like a unit factor. All right, this and this is the same thing. This means density. There is a unit factor. Of course, there's another unit factor that looks just like it. It's not density, it's dividing by density. Looks like that. All right, that might be more explanation than we need for this whole problem. It says, what is the mass of 275 mil sample of ethanol at a certain temperature, given that the density at this temperature is 0.789 grams per mil? So that means I use this unit factor. So I can take this thing and go times 275 mils. Exciting thing about this is the units do what they're supposed to. Mils cancel out, and I'm left with a unit of mass. Pull out my calculator. 275 multiply 0.789. So what my calculator's spitting out. I know the volume to 3, my density I know to 3. I'm gonna round this to 3. So while we're on the topic of density, I can take this and I can rearrange things. I'm gonna do the hardest one for students. That's like if I said, what is the volume of 350 grams of ethanol? I'm gonna write down the number of the unit, and then I'm gonna look at this and go, oh, I don't know, that's in the bottom, what do I do? Well, I'm gonna multiply by the reciprocal of the horrible looking gram, but it cancels with that gram there, and I'm left with mils. So notice, I got my mass, and I'm dividing by density, and that's gonna equal volume. So let me just ask you a question here. What is volume times density? What is volume time? Yeah, algebraically we can see if I multiply both sides by volume to get rid of it. That's what you wanted to see, is a lot of algebra type stuff. Volume. What I do to one side of the equation, I do the other, and volume over here cancel. We want to be able to cancel units like volumes or mils or micrograms, milligrams. All right, so that goes away, and we see volume times density equals mass. So we might, from this point on, not really think about a lot of unit equations. I'll bring them back up. But a unit factor is made from two things being equal. You stick one thing below the other, or you stick it on top. So you have it and its reciprocal. So when I do some density problem, I don't say, do I divide by density? Do I multiply by density? Do I multiply by volume, divide by volume? What's going on? Typically, I'm gonna write down a number in its unit. I'm gonna look at the next number in its unit. And if I can see a unit factor, I'm either gonna multiply by one unit factor or the reciprocal. So sometimes I like to get smart and say, I never divide. I just always multiply. If I need to divide, I multiply by a reciprocal. Here's the problem. I think it has lots of little twists and bends. I want 75 grams of sodium chloride. I'm gonna evaporate some seawater. It's 3.5% by mass. That means there's 3.5 grams of sodium chloride in 100 grams of water. How many liters seawater should I put in my beaker? Assume that the density of seawater is 1.0 grams per mil for seawater. All right, a lot of numbers. Multiply. Do I divide? I don't know. I'll figure it out as I go. That doesn't sound very professional, does it? I just wing it. Well, I'm gonna write down a given with its unit. There it is. Now, maybe I chose the correct place to put it. I put it in the numerator, not the denominator, and I'm gonna just hope it all works out. If it doesn't work all out, there's like a 50-50 chance. It's probably gonna work out. If it didn't work out, my answer is gonna be down in the denominator over here. The unit is, and I know that's not gonna be what I exactly want. All right, then up here, I see a unit factor multiplied by a unit factor, and this is the percent. That tells me I have 3.5 grams sodium chloride per every 100 grams of, I'm hearing people get ready to leave. As soon as it gets exciting, y'all want to leave. All right, now I'm just left with how many grams of seawater I need. Oh, look, here's the density. Am I gonna, that's my timer, I gotta get going. That's all right. That's all right. You're okay. Right there, 1.0 grams of seawater in 1 mil. What is the unit of my answer? Mils of seawater. I told you I was gonna wing it and I'm just gonna go 1,000 mils in 1 liter because that's what I like to do. All right, since I don't want you to be late to your class, now I know what's gonna happen. Those units there are gonna cancel. The units of seawater cancel there. Mils cancel there. 2 liters, ladies and gentlemen. That's how many liters? It says, I want 75 grams. How many liters of seawater should I put in my beaker? Let me do this for you here, because you'll want to see this, and then once you understand it, you'll be able to crank these out. On my calculator, I go 75 divide 5 multiply 100 divide 1.03 divide 1,000. These are the keystrokes I do on the calculator. In order of operations, I could go 75 times 100 times 1 times 1, and then on the bottom, now you'd want to hit divide and use your parentheses. Keep it all in the bottom. Hundreds up top. The 103s and the 1,000 mil bottom. So I'm lazy and I don't like to use the parentheses so much. But yeah, the math teacher will say it doesn't matter the order. You could take 75, divide 100, multiplied by 100, divide by 1.0, divide by 3.5. Right, because everybody was getting ready to leave, and yeah, so you get the good version here. My calculator, I go this number, divide by that number. I got to multiply by the 100. All right, and then I need to divide by the 1.03, and then divide by 1,000.
Which we know is 10 times.
Or I could do the whole top, like so. Then I could hit the divide key and divide by. All right, have a good rest of your day. You are welcome. That's what they pay me the big dollars.
Which we know is 10 times.